Right, as many of you may not have heard of the term life cycle assessment. Basically, it's a tool or a methodology that's now being used widely in the agricultural sector to get sustainability indicators. So in this talk, I'd like to give you an outline of what life cycle assessment is, some of the issues at a fairly high level around the development of it and relating it to environmental labelling of products, which has been its big focus, then present some information on a project to do with New Zealand lamb and its use in lamb studies and understanding some of the hotspots, and then end with some productivity-related issues. Okay, so what is life cycle assessment? Basically, it's a method that allows us to look at the total use of resources, so these are energy, water, nutrients, and a range of environmental emissions from greenhouse gases through to water quality issues and other environmental indicators, but throughout the whole of the life cycle of a product. And in a pictorial example here, if we start, say, at the bottom here with a raw material source such as phosphate rock to produce our fertilisers, transport, manufacturing, application, all of the emissions associated with the farm stage, then through to processing, where there are resources used, emissions that occur, transportation, shipping, the retail stage, where there's also resources used, including the cooking stage here, and finally even at our last waste stage, where there are various emissions that also occur. There is an internationally accepted process, or an ISO methodology, for looking and calculating these indicators. However, they're quite broad and the interpretation of them can vary. The main reason for the establishment or the highlighting of life cycle assessment as a tool has really occurred in the last 5 to 10 years as we've seen environmental labelling of products. So this was probably most prominent in the UK with Tesco's, and now we're seeing it increasingly in other parts of the world, and particularly here in France. So the government here has indicated that they would like to see labelling of all products in all supermarkets. I'm not sure whether this is still the case, but within the next year. They have started a project currently looking at a selection of products in a selection of supermarkets. And I've used an example here, that of a leg of New Zealand lamb, which has a label from one of the supermarket chains. So here, if we look at this, the customer can look at this and see in the range from low to high impact that it sits at the high end of the spectrum. If they also wish to look, they can see in more detail that there are 3 indicators that are looked at. First one on the left side here relates to climate change, the greenhouse gas emissions, then water quality, and then finally biodiversity. And again, there's a scale here from low to high, and you'll see in all cases it actually appears on the bottom at the high end of it. So I guess that leads me to my first key point about the issue of labelling and how these numbers are calculated, and that's the importance of an appropriate methodology. If we look at that biodiversity indicator that we saw in that last slide, the method is simply the area of land used to produce that. So maybe for a crop such as wheat here, that might be fine. It's the area that's totally occupied that. It's a change of land use from what might have been there before. However, if we think of, say, some extensive production, I've just got 2 pictorial examples here, one of merino sheep in the South Island of New Zealand on native tussock land country, maybe with a few legumes oversown into that country, and also here in South America in native vegetation where there is growth or use of various livestock animals. So essentially in all these cases we could argue that in fact the biodiversity is at least as good as it was in its original state, and a high level because of the range of plant and soil biota that's there. As well as choosing an appropriate methodology, it's also important that the labelling that occurs on products is fair and equitable in terms of providing the consumer the ability to make comparisons. Now, this can also occur within a product and comparison of systems. And I'll just use one example here about the importance of accounting for all of the contributors to a product. And I've used, in this case, the beef carbon footprint and some work done in North America by Palatia and his colleagues. So here we've got greenhouse gases on the y-axis, two different systems, a grazed pasture system compared to a feedlot system. The first stage in brown there is similar for both of them, and then after that we see the finishing component of it. So faster growth, less maintenance, finished earlier. We'll all tend to accept that and see that this can cause a more efficient production for that last finishing stage. However, we have to consider the fact that there's also crop grown to produce the feed for that feedlot, or emissions associated with that crop stage and its feeding and use. There are also other components of the life cycle that they raised. So, for example, soil carbon changes can lead to increased emissions or sequestration of carbon. And they gave an example here based on work, particularly there's a lot of work in France, showing effects of long-term pastures and some level of carbon sequestration, or even release of carbon following cultivation of soil for crops. So really just giving this example to highlight that it's important to do a full analysis and look at all of the sources that might contribute when we make comparisons. The other aspect is how it's reported. We look at a label and we see it's presented, for example, of CO2 equivalent emissions per kilogram of the product, or perhaps per litre. And we look down that list. It's a fairly small list, but for example, we see Coca-Cola there with the lowest number. Apples also quite low, through to milk and lamb at the higher end. These are some numbers based on some New Zealand analyses. However, in the last few years in particular, there's been a lot of interest in looking more at the nutritional information of a product, not just simply the amount of it. Coca-Cola, well, it's got no protein at all in it, and apples are also relatively low. And so we see quite a change in the order if we express the emissions per kilogram of protein. Even with milk, because it's high water content of that, we bring it down and see actually there's little difference between milk and lamb. And the beef study was quite similar to that for lamb. Okay, in terms of the process of calculating the emissions associated with a product, one of the main methodology issues that people always have a lot of discussions on is the recognition that there's often more than one product. There can be a number of co-products. So it's not only in the final, say, lamb or cattle beast, but also during the components used in its production. So here, for example, with soybean, it may be grown primarily for oil. The meal is a co-product, and so we would typically look at the economic value of those two co-products to calculate the relative split between the emissions or resource use between these two sources. In the same way, if we look at the farm stage, we have, say, sheep with cattle. Typically, the methods that are used here are to recognise that we can estimate the amount of feed eaten by the sheep and by cattle and allocate all of the emissions or resources used to produce that pasture or feed and split that between the sheep and beef accordingly. Then again, with the sheep component, there are also co-products in terms of the meat that's produced and also wool. And this example here is given based on a longer-term average financial returns for the two from New Zealand sheep meat scene. It's not just at the farm stage, this extends through to the processing level. And here I've given an example from the lamb study that we carried out, looking at the range of different co-products that are produced from an individual lamb. So if we look, for example, here we have the range across those. The red line there splits them between, on your right, the different cuts of meat, and then through to the other co-products on the left here. Now, the axis on the Y scale here could just as easily be dollars or euros per kilogram. Essentially, when we look at an economic way of splitting these, we're really looking at what is the economic value of those products. And in the case of lamb, we see the highest return is the rack of lamb. So if we used a simple economic allocation here from that one lamb, we would be providing a lot higher component of its emissions to the rack of lamb compared to something like the less favourable neck meat. So there was a lot of discussion around the process of how we do that. Is it appropriate to look at those differences between various cuts? And in the end, a pragmatic decision was made in terms of selecting an average value across the various meat cuts in terms of presenting that information for the possible consumer for labelling purposes. Okay, now to the complete study that was carried out. So this looked at New Zealand lamb produced right through to the market in the UK, including the consumption and waste stages, and produced a number, a relatively big number, 19 kilograms of CO2 equivalent per kilogram of meat. But in the end, a number is only really meaningful if we can use it to understand where are the sources of emissions, what can we do about it, and what does it actually mean. So if we look at this breakdown, in that number we see firstly 80% of it comes from the farm component of the life cycle, only 3% from the processing stage, about 5% from all of the transportation stages, and the last 12% were associated with the retailer and the consumer. If we look at the breakdown at the farm, we heard the previous talk about this. The methane emissions from the rumen tend to be a dominant part of the calculated emissions from the ruminant animals. Also the dung and urine from those animals with nitrous oxide emissions. And in fact, the fuel and electricity component were really quite small. If we look at the processing stage, there we saw that almost half of the emissions at the processor were associated with use of the various fuels, which varied. Here there was an average of a range of processing plants within the country, primarily for water heating. Electricity component associated with the chilling and freezing of the lamb, and then the wastewater was also a reasonably significant component of the emissions at that stage for the processing. When it came to the transportation, the 20,000 kilometre distance travelled around the world in the shipping dominated that, but you'll notice that even so, it was less than 5% of the total of the whole carbon footprint, so a relatively small component. And in fact, some of the bigger components were associated with the retail stage, with the refrigerant loss during the storage and display systems, as well as all the electricity use at the retailing, and then also in the cooking. And here we assumed a leg of lamb and roasting. In this case, I might just add that we also we applied the PAS, or the UK recommended methodology, and left out the consumer travel to the supermarket to buy that lamb. And in fact, when we did an analysis on that, that added up to another 7% on the top of this whole pie chart diagram here. In other words, more than the total of all the other transportation stages together. Okay, I'd now like to finish with one point around the methods that we use to display a number in terms of the products that the consumer has the choice of purchasing. Essentially, we need to be able to have an approach that can provide a signal to a producer that there are opportunities for making reductions and that they are incorporated within those labels. Now, in many countries, the greenhouse gas inventories that are used are a very simple, what's called Tier 1 method. They take the number of animals, they multiply them by a factor, and that gives the total emissions. Well, obviously in that case, about all you can do is have less animals if you want to reduce your emissions. And so a major focus has been on trying to use a more accurate estimate of the emissions by looking at an energy-based intake model for animals so that you get a better prediction of the amount of feed that is consumed relative to the productivity of the animals. And so when we did this and looked at the average New Zealand sheep meat each year over the last sort of 15 years or so, we see there's been a significant and gradual decline over time in terms of the amount of methane that's produced per kilogram of carcass weight, almost 2% a year. And then we look more closely at that, we see that compared to 1990, the New Zealand sheep farmer currently produces slightly more lamb meat from 43% less ewes. Basically, they are higher lambing percentage, they're finishing the lambs heavier and growing them faster. Essentially, higher feed conversion efficiency into product, and therefore greater productivity gains and efficiency. And it is important that these sort of things are captured and are used to show the improvements that we're making as an industry over time. So just to summarise then, life cycle assessment, it's basically a tool or a methodology to account for the efficiency of using resources and the environmental emissions that occur throughout a product's life cycle. So as a tool, it's been used mainly around environmental labelling in the last 5 or so years. But I hope you've seen with some of these examples that there are a number of quite key choices that are necessary to make in deciding what the emissions are and therefore what the label that will appear on that product that might appear in a supermarket. These are is the methodology appropriate in the first place? Are we using relevant and equitable methods? We should be accounting for all of the contributions, including the breeding animals and all of the feed sources, and considering the fact that we actually produce not just meat but a range of co-products as well. And this really, I guess, is to highlight the importance with this that we look towards a universally accepted methodology. And so those of you that were at the sheep meat session yesterday will realise there's some progress happening there in terms of the sheep meat area for carbon footprinting. And I'll leave it at that. Thanks, Pat.
Thank you, Stuart, for a very clear and informative, and for me anyway, a very easy to follow presentation. Our next speaker is Tjone Vellinga. He's from Holland. He's a livestock at the Livestock Research Centre in Wageningen. I got it half right, I'd say. And his research fields are grassland management and the environmental impacts of livestock systems. He has also been working in recent years with the FAO on the subject of calculation of greenhouse gases for the global livestock sector. So he's very well chosen for our next speaker, and his topic is reducing the negative environmental impacts of livestock production.